Hi there everyone, welcome back to Cody's Lab. So this is going to be an episode of my mining series. As you can see, I'm up at the mine, but also part of my precious metal refining and recovery series, because today I'm going to actually attempt to recover some gold and probably silver from this mine here. So let's go over and let's have a look. Now I actually caught a glimpse of a creeper. Let's see if I can find him. He went this way. Ah, there it is. Hey there, little guy. Oh, that's a little too bright. Zoom in on that. Yeah, that looks like a little baby sidewinder. Alright, well, let's leave him alone. He shouldn't cause any harm to me as long as I know where he's at and don't mess with him too much. Okay, so here we are at the site of the explosion. You see there's quite a bit of rubble on the ground here. Now, I think my objective for today is to not actually to muck this all out, but rather gather up all of this orange rock here, anything else that looks like it may contain values, and take it back home and process it. Now actually, on closer examination, I can see there's actually one explosive that didn't go off. Shouldn't be much of a problem now, since the explosives I used absorb water, and after a week it would be completely waterlogged. I'm going to see if I can dig that explosives out of this rock and do a little autopsy on it and see exactly what went wrong with it. Okay, so right here's the wire. Fuse wire. Looks like it was sheared off by the other explosives. Possibly that's something that may have caused it to not go off. Anyway, once I get this clay plug dug out of here, I should be able to just grab hold of that and pull it out. Okay, and well, that's part of it. The paper ripped. It's definitely wet, so it's not going to explode or anything. Maybe I could grab hold of this and pull it out now. Okay, so there's the explosives, and here's the blasting cap right here. This is mostly what I wanted to look at. Let's open her up. You can see the copper in the casing has been corroded. And now that I've opened up the fuse casing, you can see that the fuse actually never lit. That leads me to suspect that possibly this thing was faulty. Now, I don't actually think it was the wires being sheared off by the other explosions, because this should have lit long before those went off. So let me actually look at this. I think, yeah. So I just took the rubber bands off and opened this thing up. Pull off the fuse. Let's have a look at this. Yeah, I think I know what went wrong. Yep, that's it. I don't know if you guys can see, probably not at all. But the little wire that's supposed to go between these two is broken. So what must have happened is when we were putting together the explosives, that little wire must have broke. So this was a dud from the beginning. Okay, good to know. We'll try to make sure that don't happen again. Okay. So I'm just going to pick out this. So I'm just going to pick out this rock right here. I think it contains probably quite a bit of ore. If you've ever been around a hot spring, such as up in Yellowstone, you'll know exactly what this smells like. It seems that as I disturb this material, which probably was once a hydrothermal vent, it releases sulfur compounds, and it basically smells just like what those hydrothermal vents at Yellowstone smell like. If you haven't been up around Yellowstone, I would say that it smells kind of like propane, or maybe even a little bit like rotten eggs. So yeah. Definitely was a hydrothermal system here, which is good because that's where minerals like to accumulate. You know, the hot water brings them up from deep in the earth. Looks like our Sidewinder friend is just about thinking to leave, and so am I. So there's the sample that I decided to take. Roughly half a 5-gallon bucket full. It's still quite heavy. Let's see how much stuff I can get out of it. Okay, so I'm down here. I've got the little jaw crusher going. Let's drop in a rock and watch it get munched. That's cool, isn't it? I think this rock's a little bit harder than that one. Yeah. Some of these pieces will take a little bit longer than others. But I gotta knock them down to a nice small size so that cyanide can get to it. So here's the crushed ore. Now it's not really fine enough. You can see there's quite a few little pieces here and there. But that was a lot of crushing. And I think I'm going to call it good. See, what I'm going to do is I'm going to run this through this fine screen here. And anything that doesn't fit, I'll just save for later. Maybe I'll crush at a later time. You know what? I think that's fine enough. We're about as fine as flour right now. And here's the stuff that didn't go through. Essentially very colorful sand at this point. Yeah. So I've got a scale there, and here's my bucket of crushed ore. Put it on there, that reads 20 pounds. Subtracting a little bit for the bucket, let's call that 15 pounds of crushed ore. Okay, and so now I want to dissolve the silver and gold from the ore. So first thing I'm going to need to do is I'm going to need to add a little bit of lye to make sure this stays alkaline. I'm going to add in a little bit of cyanide. I think, yeah, let's just throw that whole pellet in. Plenty. I'm going to dissolve that into the ore with a little bit of water. Like this. Now once the... Oh, wait. Now to help the process along, I'm going to add in a little bit of hydrogen peroxide to increase the oxygen content of the solution and make the gold dissolve quicker. Now, 1 gallon of water seems to be just right. And now to recover the gold and silver in a way that is extractable, I'm going to add in some activated carbon, which I have washed and de-dusted. And the idea is I'll be able to extract it from the slurry using a screen such as this. So add that in there, and that'll absorb the gold and silver that get dissolved. Carbon will also absorb the copper, but there's not really enough there to really worry about. Other ores, it may be a problem. So here's the solution after it's set for a couple of days. I have been stirring it every now and then to input air and to help mix the solution so that the carbon can absorb any dissolved gold. And I think it's probably about done. So now, I'm going to use this screen here to sift out the pieces of carbon. As you can see, I've recovered all of the carbon, and I'm just rinsing it now to get rid of all the rock. So all I should be left with is carbon and maybe a little bit of precious metals. So now I'm left with a bucket of cyanide solution. Now there wasn't quite as much cyanide as I showed putting in, because I actually took the pellet out before it completely dissolved, because honestly that was way more cyanide than I needed. Now I could reuse the solution. It's really ripe and ready to be dissolving more gold, but I don't actually intend to reuse it, so I'm going to add in a little bit of sodium thiosulfate here. Now, thiosulfate is not nearly as fast at destroying cyanide as bleach is, but the byproducts that it forms are actually even less toxic. Now, sodium thiosulfate requires a secondary oxidizer to destroy cyanide, which I have plenty of in the air. Industrially, they may use hydrogen peroxide, but I'll just use the air today, which means it'll be a rather slow process, but I got time. If you haven't already noticed, the process I'm doing here is very similar to what I did to recover the gold from the dishes that I extracted the gold off of. And to be honest, the amount of gold I'm expecting is probably about the same. So let's get this thing on. And let's set it at 800 degrees and cook that for several hours until the carbon's completely burned away. This time, however, I'm not going to bother grinding up the carbon. It didn't seem to really make a difference. Okay, so it's the next day. It appears like all of the carbon has been burned away. Now, don't worry, I didn't let this thing run all night, but it still took right about 3 hours. Burning the carbon is kind of difficult, but trust me, it's way easier than stripping the gold out using a chemical process like they do in industry. I of course know how to do it, and perhaps I'll make a video on that process sometime, but not for this little test. So now I'm going to add about a spoonful of gluten-free assay flux. Many people have been asking about it, so here's the label on the container. As you can see, it contains lead, but no wheat flour. And that there will help collect together all of the precious metals into a bead of lead. So now I've moved the material into a graphite crucible so I don't actually have to have flour. The carbon will reduce the lead. And put into a furnace, and I'm going to heat to over 1800 degrees. And don't worry about the leaves. If they catch fire, it'll only make it cook faster. Alright, we're at temperature. Let's pull this thing out of there. Yeah, the beads aren't working together. Let's actually put that back in. Let's add just a little bit more flux to it. A little bit of borax ought to help that. Okay, let's put it back in. Okay. Yes, that looks much better. Let's pour it out on this plate, let it cool. Oops. Oh well. That'll work. Okay, so I can already tell you that this does not contain the 2 grams of silver that I was expecting. But let's put this in a furnace to burn away the lead and see exactly what we have. Well, there's a bead of something down in there. Let's get a closer look. There we go. It just solidified. And actually, by the way it acted, I'd say that's mostly silver, as the dissolved oxygen just suddenly came out of solution. Well, let's see just how much I have here. Let's put the bead on the scale. 0.1 grams, about 100 milligrams. And since it's mostly silver, it's not much. Now, according to my assay that I had done, I should have expected something like 2 grams of silver from that much rock. So either I was unable to recover it, the assay was wrong, or simply I just did not use enough carbon. As a quick Google search on my phone reveals that activated carbon only dissolves about 4,000 to 8,000 grams of gold per ton, and honestly the gold is more attracted to the carbon than the silver is. Considering that I only had a couple ounces of carbon, it would make sense that the amount of silver that I could actually absorb onto it would be low, which means most of my silver might actually still be in the solution, which is unfortunate because I've already destroyed the cyanide. So I'm going to take this bead and drop it into a test tube with nitric acid. There we go. Now if it's got gold, it should turn black. Indeed it is. Now if I wait for a little while, I should have a black powder as my gold. Looks like I'm going to have to add a little bit of water to dissolve that silver nitrate. There we go. The gold's not soluble, so it should be left as a fine black powder. So I'm just getting done washing out the silver nitrate from the gold powder. Here we go. Now to show that it is silver, I'm going to put in a little bit of salt to form silver chloride. There we go. And I'll recover the silver from that. But right now I need to get this gold. I think the easiest way to do this would be to just put a piece of paper over the end of this, shake it up, and drop it onto the paper. There we go, I think I got it. There it is. So I just transferred the black powder off the paper and into a little melting dish here, as you can see. Now, I'm going to add a little bit of lead to help collect it into a single bead and put it back in the furnace. The silver chloride does look a little bit weird after exposing it to the light, but now I'm going to change it back into silver metal. There we go, pure bead of silver metal. You guys have already seen me processing the silver many times, so there it is, a little bead of gold. Let's pull it out. Well, it looks yellow enough, but it's probably less than a milligram's worth. So here's the two metals that I've extracted side by side. You have gold and silver. According to the assay I had professionally done, I should have expected about 2 milligrams of gold. I got about half a milligram, so I had about a 25% recovery on that. I didn't do nearly as well for the silver, but I think definitely more carbon would have helped. Either way, it sure isn't very much. Out of 15 pounds of rock, I got just a few cents worth of metal. Definitely not economically viable. I guess that's why the mine was abandoned originally. So really there's no sense in me pursuing the metals any further. But anyway, hope you all enjoyed. I'll see you next time.